Okay, so this is our last section for rational expressions. We're going to be solving. We're going to use this skill later on, um, but we're just going to briefly go over it now, and we'll apply it to other things in further lessons. Extra math in that quiz, if it's more than 10 minutes, taking too much time. We don't want to waste any time. The year's coming up and ending pretty soon. That quiz, if you're done with all your extra math, etc., your codes are here. This is basic time telling, something you would learn in second grade. Important skill to have. There's lots of clocks that are still analog with the hands and no longer digital. I don't want you guys to walking around and see a clock and not know how to tell time. If you think about it, the fanciest watches out there, Rolexes and etc., are still classic and written in analog, so time is important. Okay, so here's a review. We need to get common denominators before we add or subtract. Okay, so I'm going to pause the video. I'm going to multiply this one on both sides so that we can see what we're missing. Okay, so looking at this two rational expressions, this one has an x plus 2, this one doesn't, so we gave it 1. This one has an x minus 1, and this one doesn't, so we gave it 1 over there. Again, these represent those gigantic ones I love to draw. And on this side, the same thing. This represents a giant 1. Okay. We're going to multiply the numerators, and because these are binomials, we have to distribute. So I have x squared minus x, and on this side, I'm going to distribute the whole negative 4. That way I don't have to deal with the negative later. Negative 4x and minus 8. Okay, we'll combine our like terms, which are these two, and we'll have x squared minus 5x minus 8. And our denominator stays the way that it is with these two items. And if you could factor out the numerator, you would, but in this one you can't. We're going to do the same process over here on the left side. The one thing that is going to change is I'm going to factor out the denominator on the b squared minus 1 first. Okay, so what we have so far is, I factored this out, the b squared minus 1 is b minus 1, b plus 1, difference of squares. If you forgot how to factor this, that is going to be 6b, unit 6b. The results are on the wall, how well you guys did or didn't do, factoring difference of squares. Okay, so that's a little bit of a review, actually a lot of a review. Our denominators are the red and the blue, b plus 1 and b plus 1. And our denominators are the b minus 1. Okay. Our numerators across the top, all I have here on the left is just that 6. And then on the right, I have this negative b. Again, I'm going to distribute negative b squared, negative, and a negative make a positive 1. Oh, sorry, 1b. I'll rearrange this, so the numerator should be negative b squared plus b and then plus 6, and our denominators stay the same. Denominators stay the same, and I'll factor out the numerator, and we'll see if we can cross anything out. We should have negative b plus 2 and b minus 3. And the denominator again stays the same as it is over here, and it doesn't look like anything's going to cancel. So you can leave it like this, you can leave it like this. As long as you know that those two items are exactly the same, one is factored, one is not, that's okay. Okay, again, vocabulary words aren't changing because they're important, and I'm going to, again, go through these regularly. If you don't know what these mean, make sure that you ask. If you don't want to ask, make sure you write it down. We can go over it in our small groups. Okay, now this is the first time that you'll notice something drastically different than everything else we've been working on so far. Never in this unit have we had an equal sign before. So now we're going to go back into solving equations. Okay. The unique thing about this, I'm going to show you two different ways to do this. So the first one is a very review type idea. Okay. Now, again, we're going to split this equation in half because it is an equation and we have two sides. And what I'll do is I'm going to identify two like terms. On the right side, I have this n squared, well, a denominator of an n squared. And on this side, I also have a denominator of an n squared. Now, I could simplify one side first and then solve for it, but because I have the same denominators, I'm going to move these over. Okay, so I'm going to move the like terms to the same side. So this takes you back to Unit 2, Unit 2C or 2D, I believe, solving multi-step equations. So I'm going to subtract this first. Minus 1 over n squared. These two, that's our additive inverse property, so add and then now subtract. These two go away. Every inverse creates an identity. I'm going to add 0, which doesn't do very much, and I'll bring this down, 1 over n. Now, like we did before, every time I do an action on one side with an equation, I can do it on the other, so I'm going to do the same thing here, minus 1n squared. Because these are both n squareds, I can combine these two items. The denominators are the same at least. 4 minus 1 is 3 over n squared. Okay. Now 1 over n plus 0, that goes away. That's an identity. And then we could solve this equation. Okay, we can solve this equation. I was able to review some of this with you guys last time, and I wasn't able to review with everybody, so we're going to review proportions. This is cross-multiplying. So in order to solve these equations, I'm going to cross-multiply them. N times n squared, well, n squared, sorry, times 1 is just going to be, I'll rewrite it here, n squared times 1. And that's equal to, it's in a different color, 3 times n. 3 times n. Now I'm going to factor this on the left because it's actually going to be broken down pretty easily. So on the left we should have n squared, which can break down into n times n. Times 1 doesn't change anything, so I'll just leave it out. And on the right side, 3 times n. That's just another way to write multiplication. To solve this equation, I need to get n by itself. This is an n squared. This is an n. So I cannot combine those and move them together. What I can do is do another inverse. Divide by n on this side and divide on n on this side. So that way I can get rid of a couple of these. Every inverse creates an identity. They go away. The nice thing about that is after that, all I have is on the right side a 3, and on the left side an n. N equals 3. We will have an equal sign at the end. Okay, I can do the same process for this one. Same process. So I'm going to pause it and simplify my equation a little bit. Okay, what you'll notice is that this n squared and the n squared to the left are the same. So I'm going to move them to the same side of the equation. Like terms and like terms, they go together. So subtract on both sides. And then I'll be able to solve a lot easier once everything is gathered together. Okay, so 2 minus 1 is 1. Okay, so this 2 numerators subtract each other. It equals a 1. Denominators, they stay the same. Okay, on the right, the inverse, they go cancel out, and I'll bring this 1 over 2n down. Cross multiply. 1 times 2n, so 2 times n times 1. I'm factoring early. And on the other side, n squared times 1, 1 times n times n. That's 1n squared. Solve our equations by doing the inverse on both sides. I see a 1n on both sides and a 1 and n. Divide by 1. Divide by 1. Those go away. Those go away. Divide by an n. Divide by an n. Those go away. Those go away. Final answer, I'll bring down this n equals 2. Okay, now again, since everything is the same as in our denominators, we'll move things over. Okay, so like I said, we're going to move things over. I'll draw this line down the center. Again, I identified these two items as being the same denominator, this one and this one. It's kind of like having like terms because I can add and subtract those two together. So I'm going to first move one over by subtracting it. I'll move this one over because that way I only have the n plus 1 on this side. So minus 6 over n squared plus n. These two are inverses. Every inverse creates an identity. Now let me move everything over, and if you're having trouble seeing how that worked as far as subtracting, I'm going to write this. If I do it to one side, I'll do it to the other. Negative 6 over n squared plus n. And then I'll bring this item down, this one. Positive 1 over n squared plus n. What you notice is the denominators are the same. So when I combine those two together, they make one item, which is negative 6 and positive 1 make negative 5 over n squared plus n. On the left, I'll bring this down, 1 over n plus 1. Cross multiply these two, negative 5 times n plus 1, and on the other side, I'll have n squared plus n. Now the reason why this one's a lot trickier when you look at it is it's going to require a little bit more factoring on a different level. Again, this is binomials. Okay, so I can't factor like I did before. Every time I have a binomial, I'm going to make sure that I factor out a GCF first, or if I can, difference of squares. They both have an n, so I'll take one out and have an n plus 1. And I can check n times n squared, n times 1, n. Good. This factoring, it works. On the other side, I'll just bring this down, negative 5 and n plus 1. Those two are still equal, and I can identify an entire factor that is the same. So I'll divide by n plus 1 and divide this side by n plus 1. Inverse creates identity, n all by itself, and negative 5. Okay, this one I'm going to do in a slightly different way, just so you can see how to find common denominators before you solve. Okay, very, very important. This is negative 1 over 1. Okay, so when I have a negative 1 over 1, I'm going to multiply this entire term by x plus 4 over x plus 4. Now again, I'm multiplying by 1, so nothing changes. Okay, and what that will do is give me a common denominator. So not all of them will work so well. This is one of the ones where you might need a common denominator. So I'll rewrite this first term, 4 over x plus 4. That's this one. And on this one, negative 1, I'll distribute. Again, this is from the last unit. We'll have negative x minus 4 over x plus 4. Now all my denominators are the same. I can add those together, equals 7 over x plus 4. Okay. Now from here, because my denominators are all the same, this is a trick that you'll see a lot of mathematicians use, is they'll eliminate the denominator. Now I'm going to multiply this by one number to get rid of everything, but because I'm doing it on both sides, it's okay. X plus 4 over 1. And multiply it to every item. When I multiply it to the one in black, numerator, denominator cancel out. When I multiply the one in red, numerator and denominator cancel out. And again, these two cancel out. I'm left with just 4, and then the minus x minus 4 equals 7. Combine my like terms, 4 minus 4 cancel out. Negative x equals 7. Divide by negative 1. Divide by negative 1. X equals negative 7.